Okay, so right now we're doing functions and equivalent algebraic expressions. So a rational expression is a quotient or a fraction whose numerator and denominator are polynomials. So notice you have a rational expression. It's just like a fraction, but we have x terms in it, right? Okay. Do you remember that fractions can be simplified? To simplify a fraction, we divide out any common factors. So for example, 8 divided by 10 is the same as 4 times 2 equals 8. 5 times 2 equals 12. You know that the 2 divides out, right? 2 divided by 2 is 1. So we end up with the 4 over 5. If we had 25 over 150, you could factor that. You have 25, right? 6 times 25, just another example. And then we could just reduce that, and that equals 1 over 6, right? So that's something you did in your earlier grades of mathematics. But we do a similar thing with rational expressions. Rational expressions, and again, they're fractions with variables in it. It could be x, it could be t, it doesn't matter. It could be any letter of the alphabet, actually. And these are your variables. So rational expressions can be simplified using the same idea as reducing fractions to lowest terms. We want to make sure the numerator and the denominator are expressed as products. That can be done by factoring, which we've been doing for a couple of days. Then we divide out any common factors. So let's do a couple of examples. Before I begin, what can you tell me about fractions when it comes to dividing by 0? Like, for example, 5 divided by 0. Can we do that? No, it's undefined, right? So we have to look for what values of t or x does our denominator equal 0, and we have to state those as restrictions. Okay, so we're going to do lots of examples of those. All right, so if we want to reduce this to lowest terms, we're going to factor first, just like we did with the 8 over 10. That's nothing new. So we take out the greatest common factor. That's 4. Uh-oh, my bad. Let me just fix that. That's going to be times t plus 2 all over 4t. Now, 4t divides into 4t, that equals 1. So we're just left with t plus 2 over 1, which is just that. Can you tell me what can t not equal? Right? Remember, we can't divide by 0, so that means t cannot be? Right, because 4t cannot be 0. Divide both sides by 4. T cannot be 0. So here's this expression is equivalent to this expression. These two guys with the restriction, right? This guy has to have a restriction, are equivalent. It has to have a restriction in order for this to be equivalent to that. Equivalent. I just want to spell that right. Can I explain anything better? Anything at all? Okay, let's look at this guy. Again, we're going to factor just like we did with fractions, and then we're going to divide out the common factors, and then we're going to state restrictions. So we'll factor this. Oh, here, I'll do it down here. X minus 5, x plus 2 is how we factor the numerator. See, I'm assuming you know factoring by now. Divided by x plus 2. So I think you can see that the x plus 2 divides out, and we are left with x plus 5. Does anybody want to tell me what the restriction is? Right. And the way you get that, you can go x plus 5 cannot be 0. Add, subtract 5 from both sides. X cannot be negative 5. So x cannot be negative 5. So I think you can see that this expression is equivalent to this expression. But this one needs a restriction. Yeah? X cannot be minus 5. Oh, yeah, yeah, yeah. My bad. I'm so sorry. Thank you for pointing that out. I'm very grateful you did that. I don't know. Okay, so x minus 5. So x cannot be. I don't, now that I've totally. So x plus 2 cannot be 0. X cannot be negative 2. So x cannot be negative 2. Just keep me on the ball, okay? Are we good? Yep. Oh, that's what the denominator. See, that whole expression cannot be 0, so x plus 2 cannot be 0. Any other comments or concerns? This part? This? No. This is rough work. That's up to you. No marks are allocated for that rough work, okay? That's just rough work. I'm doing rough work right here, okay? Maybe I should box that off so that we don't have any confusion on that. On a test, the on a test, the way I photocopy it is you write your answers here. The back of the test is blank, and you can do your rough work there. If you want to pull it apart and staple it when you hand it in, that's fine with me, okay? So don't forget, your first test is a week Monday. Your study notes will be due on Thursday. Don't start your study notes till Monday. I'll give you a rough guideline of what I'm looking for. All right? Okay. Rational expressions cannot be defined when the denominator is 0, because you know you can't divide anything by 0. This kind of thing, as I mentioned before, is not defined. We cannot do that. If I were to plug it in a calculator, and if I were to go 5 divided by 0 equals error 2, whatever that means. I don't know what error 2 means, but it's just telling you we can't divide by 0, right? Okay. All right, so if we look at 2a, this has already been simplified for us. What do you think? I think this question is just asking for the restriction, okay? Yeah, we'll just do the restrictions. Okay. Okay, so what is the restriction on 2a? Yep. Perfect. What's the restriction on this guy? Yep. Does anyone want me to show you how we got the 3? If you want me to, just raise your hand. Okay. Now, let's look at this guy. Maybe we should do some rough work here. 3x plus 4 cannot be 0. 3x cannot be negative 4. Divide both sides by 3. X cannot be negative 4 over 3. So x, there's our restriction, and here's our rough work, okay? Oh, I already put rough work. I don't want to do it again. Okay, for part D, there's 2 factors in the denominator, so that means we're going to have 2 restrictions, right? Do you guys know the zero product property? I don't blame you if you don't. I don't expect you to know. Property. What this tells us is, it's a little mathematical, it's either a theorem or They might call it something else. But if you have, when you're multiplying two numbers and they equal 0, right? Let's say. How can that happen? Well, if A equals 0, then A times B equals 0, right? Because 0 times anything equals 0. If B equals 0, then A times B will equal 0, because anything times 0 is 0, right? That's just a little property. So we have something times something, so you know you have two restrictions. You have either x cannot be 0, or x plus 5 cannot be 0, or x cannot be negative 5. Good? Can I explain anything better? No? Okay, let's do this guy. For each expression, simplify fully and state any restrictions on the variable. So what's step number 1? Hint. Factor the numerator and the denominator if possible. Well, we can't do anything with the numerator. That's just a y. So let's factor this. What's the greatest common factor? 2y. Okay, so we can divide out the y. Yeah, thank you. Thank you. Thank you for helping me out. I really appreciate it. How's that? So we divide this out and we are left with 1 over 2 times y minus 2. So we have to look at this to state our restrictions. Can anybody tell me what the restrictions are? 2, anything else? Y cannot be 0 and y cannot be 2. That's our equivalent expression. This is equivalent to this. We have to have the restriction in order for it to be equivalent. Okay, let's keep on going. Sometimes they get a little bit more complicated. Let's see. X, now we have a lot of factoring to do. I'm assuming you're okay with the factoring. If there's an issue, you can come and see me. At lunch, second half of lunch. If I'm not here, you can always go to the math department, room 201, to find me. Okay, so this divides out, and we are left with anyone want to tell me the restrictions? X cannot be what? 5? Well, 5 is in the numerator. We don't worry about the numerator. We only worry about the denominator. Minus 1 and minus 1 and yeah. So remember, restrictions are stated on the denominator. Restrictions are stated on the denominator. No, yeah, not the numerator. Denominator. Tell me, which of this does not exist? That's a R. Which of these do not exist? Is 0 over 5 okay? Yeah. This is good. This is, we can't do that. We can't divide by 0. Okay? Okay, what do you think? What can we do to simplify this? Huh? Factor? What are we going to factor out? Okay. Do you want to do it out of the numerator or the denominator? Yeah, either. Yeah, it doesn't make much difference which one we do. We're going to end up with the same answer. So we're going to factor out a negative 1 out of the numerator. That would make that negative 3 divided by negative 1 is 3. And x divided by negative 1 is negative x. So now this factor looks like the denominator, right? So that means we can divide it out. That equals negative 1. And what is our restriction? X cannot be 3. But on a test, don't just write 3, write x cannot be 3, okay? This is what you need for a complete answer on your restriction, and this is equivalent to this. All right, uh-oh. I want to just go over factoring by decomposition, because your grade 12 teachers, some of them will want to see that. So well, 3 minus positive 3 is 0, right? 3 minus positive 3 equals. If it was negative, we'd end up with a 6. So 3 minus a negative 3 is 6, and that would be okay. Okay, so we have 2y squared minus y minus 15. We need two numbers that add together to give negative 1, two numbers that multiply together to give negative 30. And that looks like I'm decomposing the middle term. Negative 6, 5, negative 6, 5. So decomposing the middle term, we have 2y squared minus 6y plus 5y minus 15. Now I can group those two terms and those two terms. So now I have 2y times y minus 3 plus 5 times y minus 3, and that equals 2y plus 5 times y minus 3. Let's do this guy. This is all our rough work right here, right? Maybe I should write here. 4y squared minus 13y plus 3. So we need two numbers that add together to give negative 13, two numbers that multiply together to give 12. So it looks like it's going to be 13. No, it's not going to be 13. Minus 1 Why am I not waking? Minus 1 minus 12. Okay? Minus 1 minus 12 equals negative 13. So we can decompose 4y squared minus 12y minus y plus 3. We'll group these two together. Is 4y times y minus 3. Factor out a negative 1, we'll get a y minus 3. And that's 4y minus 1 times y minus 3. Okay, I'm just reviewing factoring by decomposition. So the numerator equals 2y plus 5 times y minus 3. The denominator equals 4y minus 1 times y minus 3. This divides out 2y plus 5 over 4y minus 1. And what are our restrictions? How many restrictions do we have? So what would they be? Sounds good to me. So basically what we did was we factored the numerator and the denominator. We divided by the common factors. Zap, zap, right? State the restrictions on the variable, which we did. Can I explain anything better? Okay. Okay. I want to show you what some of the graphs of these look like. So this is a really complicated graph here. You have a branch here. You have another branch here. You have another branch here. It's a graph of f of x equals 2x plus 1 over 2x minus 3 times x plus 1. Many of you have not seen this symbol, but f of x is another way, to write y. It's just another way to write y. See, here they wrote y, but we could have wrote f of x equals blah, blah, blah. It's just another way to write y. So if you look at this, right, if you look at this expression, what are the restrictions? X cannot be what? What can x not be? And? Right. So if you look at this graph, and I'm just going to draw 3 over 2 is like 1.5 basically. This dashed line represents an asymptote. This line is x equals 3 over 2. So this is called an asymptote. This is a graph of the line x equals 3 over 2, and an asymptote is a line that the graph approaches but never touches. I guess that's written for you right here. Is a line that the graph approaches more and more closely but never touches. So notice, as this gets closer and closer and closer to the asymptote, it doesn't touch it. As this gets closer and closer to the asymptote, it never touches. So the graph does not exist at x equals 3 over 2. The graph does not exist at x equals, the graph does not exist at x equals 3 over 2. Nowhere along this line going up to infinity and down to infinity, this graph will never touch it. Equivalently, x equals -1, which is right here. The graph of this, the equation of this line is x equals -1, and that's another asymptote. As the graph gets closer and closer to this line, it never touches. This is just an inaccuracy in drawing, but graphs never touch the asymptote there or there. Can I answer any questions? And notice that you can pick off the asymptotes in the denominator. Or at x equals -1, right? Or at x equals -1. There is a horizontal asymptote at y equals 0, or the x-axis. The graph does not cross the x-axis, right? It gets closer and closer but never crosses. But I just want you to worry about the x restrictions. We're not going to worry about the y restriction. Yeah, but the equation of the y-axis is x equals 0, not y. Y equals 0. Here, hold it a sec. If I have a graph like this, the equation of the x-axis is y equals 0. The equation of the x-axis is y equals 0. The equation of the y-axis is x equals 0. Do you see the difference? Along here, all values of x are 0. Along here, all y values are 0. Okay, let's graph this guy. Y equals 3x squared plus 5x minus 2 over x plus 2. So let's simplify it. 3x times x. I have a feeling if the denominator is plus 2, one of the factors must be plus 2. So let's see. 3x times x is 3x squared plus 5x, so we better subtract 1x, plus 6x minus 1x equals 5x minus 2 all over x plus 2. So the x plus 2 divides out. What can x not equal? So let's graph it. This is a line, right? This is a line in the form y equals mx plus b. Can you tell me what the y-intercept is? Our y-intercept is -1. So that's right there, right? -1 is right there. The y-intercept is where the graph crosses the y-axis. What's the slope? 3, right? So the slope equals rise over run. Remember that stuff? You got to remember that stuff. Equals 3 over 1. So for every 1 it goes over, it goes up 3. 1, 2, 3. 1 over, 1, 2, 3. 1 over, 1, 2, 3. Now we have to remember x cannot be -2. -2 is there. Our graph will not exist there. Okay, 1 over, 1, 2, 3. 1 over, 1, 2, 3. We have to draw an open dot to indicate the graph does not exist there. Over 1, down 3. The graph does not exist at that point. At x equals -2, the graph does not exist. Can I explain anything better? Yeah, do you see how x cannot be -2? So at that point, right at -2, there's no line there. It's just an open space. There's a hole there. Because the denominator, right, x plus 2 cannot be 0, x cannot be -2. So the graph does not exist when x equals -2. See how x equals -2 here? Can I explain anything better? Yes. There. Why does it start here? I could have started it there, but the y-intercept is -1, so right away I know I have a point there, right? No, that's okay. Just ask your question, because you haven't had math since last year. So it's easy to forget. I understand that. Only if they ask you to. See how they say graph the function or graph it? Yeah, it's asking you to graph it. Okay. Huh? You might have some homework questions involving graphing, but only graph it if it asks you to. So, do you want me to graph it again? Okay. When, yeah, it's just a line. Oh, yeah. If it was a parabola, it would be x squared. Okay, let's try one more. Okay, simplify the expression, state all restrictions, graph the function. Okay? All right, so we have f at x. Remember, that's just another way to write y. This really helps when you do calculus, so we're trying to get you used to different notation. Another way to write y. So let's factor this expression. X minus 3 looks like this will be 2x times an x plus 1 minus 1 looks like what it would be. And the bottom we have x minus 3, x plus 1. I'm just going to x squared minus 2x minus 3. Ooh. How many, looking at this equation, how many holes are we going to have in the graph? You're going to have 2 holes, exactly. 2 restrictions, 2 holes. So let's divide it out. So x can't be 3 or -1. Okay, our y-intercept is -1. The slope is 2, right? Slope equals 2 over 1. Y-intercept equals -1. So for every 1 it goes over, it goes up 2. 1 over, up 2. 1 over, uh-oh, x cannot be 3, right? X cannot be 3. There's a very small point there where a graph does not exist. 1 over up 2, 1 over up 2, 1 over down 2. Graph does not exist at -1. Oopsie daisy. I have to do an open hole when x equals -1. Right? 2 over down 2. So it has a positive slope. It's rising upward to the right. So let's just draw that really carefully without going through our holes. Can't go through the holes, you know, that kind of messes things up. So this is the graph of f at x equals x minus 3, 2x squared plus x minus 1. You should label your graphs. I forgot to do it on the other side, but so there's our answer. There's our graph. Is there anything I need to explain some more? Ooh, the next one's a humdinger. This is called a square root function. And you'll learn more about this in Unit 3. We're going to cross this out. Can you tell me what the restrictions on this graph would be? Anything? X cannot be 3. Are there any other restrictions? We cannot take the square root of a negative number. That's right. You can't square root a -5. We can't do that in the system of real numbers. In grade 12, you're going to learn about complex numbers, and you can play, you know, kind of extend your use of square root and negative numbers. But in the real number system, we cannot do that. So for this guy, x plus 1 has to be greater than or equal to 0, or x has to be greater than or equal to -1. So that's another restriction. There's two restrictions here. X has to be greater than or equal to -1. I'm just going to draw a table of values here to graph. We're graphing the square root function. So -1, -1 plus 1 is 0, square root of 0 is 0. If we go 0, when x is 0, 0 plus 1 is 1, square root of 1 is 1. We need a 3, but x cannot be 3. We have to remember that when we graph it. Let's see. When x is 8, 8 plus 1 is 9, square root of 9 is 3. I'm just picking easy x's that I can take the square root of. So when x is -1, y is 0. When x is 0, y is 1. When x is 3, y is 2, but y cannot equal 3, right? X cannot be 3. My bad. I should be 1 over. 1, 2, 3. X cannot be 3. And when x is 8, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So this graph looks something like this. Can I explain anything? Anything at all? This is called the square root function. You're going to learn more about that in Unit 3, but the homework introduces it here. Square root function. I think most of you are familiar with two functions, the linear function and the quadratic function. Can I explain anything better? Okay. I'll get this up on the internet.